Point load test is carried out on core rock, specimens or irregular rock fragments to obtain the point strength index IS50 and unconfined compressive strength. This is a quick sample test and a cost-saving one. The failure load P and the distance between platens D are measured to obtain the uncorrected point load strength P over D squared. A correction is applied to account for the specimen size and shape, and the unconfined compressive strength is obtained from the acceleration equation. Depending on the specimen's geometry, three types of tests can be performed: diameter, axial, and irregular. To determine the compressive strength of rock, specimen from irregular lump test. For the theory part, point load strength is an indirect tensile test, and it was used mainly to predict the unaxial compressive strength, which is known as the general purpose for rock strength classification. To get the rock classification, IS50 should be achieved at it half the coloration with unaxial compressive strength. On average, unaxial compressive strength is 20 to 25 times of point load test. However, tests on different types of rock, the ratio can vary between 15 to 50. So, the error of up to 100% are possible in using an arbitrary ratio value to predict the compressive strength, and the IS50 is approximately 0.08 times with the unaxial tensile or Brazilian tensile strength.
The procedure: 1. Rock sample were prepared. The center point of cross-section area at both top and bottom. Sample surface is marked as the reference point for placing the rock sample in the point load tester. Number 3. The upper width and the lower width of rock W1 and W2 is measured using vernier clipper. 4th, width rock width is calculated and the data is recorded. The center of the rock sample is then placed in the point load tester and close the platen until the platen hold the specimen. 5th, pressure is applied on the rock sample until failure. And lastly, the rock can withstand, which is the failure load P is recorded. Then the steps were repeated using another rock sample. Okay, thank you.
Data calculation and result. From our experiment, the data obtained for 3 tests was load 8, load 7.5 and load 7, which has diameter on 24.62, 51.68, 51.0. From here, we can get our calculation for cross-section area A. Cross-section area A is equal to W times D. From here, we can get our cross-section area is 787.59 millimeter square. And then, from the previous formula, we borrow A to find equivalent core diameter DE square. DE square is equal to 4A over pi. DE square then will be 1002.796 millimeter square. Only from that we can find our size correction factor F. F is equal to TE over 50, the power of 0.45. After using this formula, we get that our F is 0.814. From here, we can find our IS. IS is uncorrected point load strength. IS is equal to P over DE square. By using this formula, we get our value is 7.978 Newton millimeter square. Using the formula of IS equal to 50, we get our IS is equal to 6.494 Newton millimeter square. Only from that, we can get our approximation of UCS value. Our UCS value for this test was 149 and 29 megapascal. From the calculation, we should be repeat for test number 2 and number 3, and we will get the UCS value is 95.68 and 90.36 megapascal.
Discussion and conclusion. From the result obtained, US value rock sample 1 is 36.72 MPa, rock sample 2 47.28 MPa, rock sample 3 21.6 MPa. The higher the unaxial compressive strength, the stronger the rock. Therefore, we realize that sample 2 has the highest load strength because it has the highest US value, followed by rock 1 and 3. The objective of the experiment has been achieved. We can determine the compressive strength of rock specimen by using point load test. Conclusively, the USC value for the 3 samples has been determined, which are first 36.72, sample 2 47.28, and sample 3 is 21.6. Thus, we can conclude that sample 2 is the strongest among the sample 1 and sample 3. Thank you.